Alright, welcome everybody to the first day of week 15. So, she's going to start singing about Unordered Maps. That's funny. Yeah, Alicia Wilder does a lot of alt-rock stuff, like covers with the Smiths and the Pixies and Nirvana and stuff like that. Pretty good. Good singer and plays guitar at the same time, so good music. For the 12 o'clock section, I played some Indian new metal, so you can see that on the music channel on Discord. So we're going to talk about a few things today. So these things we are going to talk about is we are going to review CN versus, and I really mean versus, getline, because that's something that a lot of you have been asking questions about on Discord. Why is my getline not working? We're going to go over that again. It's important. Or you can always use my read lib if you want. We're going to talk about using range-based for loops in 2D vectors, because we're going to be doing the type system, right, for Pokemon. Oh, also, if anybody has an AFK partner, please message me right now, and you will be issued a new partner. So, in the previous class, I had 3 students message me, so if you have been an AFK partner, you should probably check your group on Canvas and see if you've been assigned a new partner, and if so, get in contact with them, because the deadline's in 2 days. So, the only way to fail this class is by not doing any work, really. Alright, so, are there a lot of AFKs? There's about 6, I would say, out of the 80 or so in this class. Not a whole lot, but it's enough that it is kind of a hassle for me, because the person's like, hey, this person hasn't responded to me, and then I shuffle them, and hey, this person, and they shuffle them, and if I have one person and not another, then it's like, all right, who do you partner them with, So, your partner hasn't reached out, well, message me. If you want a new partner, message. And I will find you a new one. Range-based for loops. We're going to learn more about the preprocessor stuff, like define and if-def and if, else, elif, and if. So we're going to go over preprocessor stuff today, and then probably a little review of maps type system. There we go. All right. So let's take it from the top. String S1, string S2, CN into S1, getline from CN into S2. So this is what I mean when I say you can't mix double right arrow and getline easily. Okay. My advice to new programmers is stick with either double right arrow or stick with getline, and then you're not going to run into the problem that I'm about to show you, which some of you know about because it burns a lot of students, because it's a badly designed system, in my opinion. That's why I made a better system called readlib. It doesn't have these problems. So let me go over kind of the underlying theory of how Iostreams work, and then probably the reason why this happens will be a little bit more clear to you. So this is a faucet, believe it or not. That's a faucet. And, I don't know, galaxy water comes out of the faucet or something, I don't know. Okay, so we're doing CN into S1, getline into S2, right? And let's say we're going to type hello space world. This is the end of the faucet here. Okay, so the Iostream is literally like a stream of water. Characters come out of it one at a time. H, E, I'm not going to draw the single quotes, that's going to get annoying. Okay. H, E, L, L, O. I will draw it for the space, just because how How else do you draw space? I don't know. Hello, W, it's a W, believe it or not. O, R, L, and D. And then they hit return. So this is what's in the input stream. HELLO space WRLD, return key, enter key, new line, whatever you want to call it. Okay, and all that will just sit there in the input buffer. This is something called the input buffer. And what happens is it just sits there until something like this happens. So when you say CN into S1, are you doing the thing? You doing the thing? Can't switch anymore? Cool. All right, so when you do a CN into S1 like this, what happens is it reads double right arrow, reads, it first discards all leading white space. 2 reads one character at a time into S1. And then 3 stops before reading the first white space character without discarding it. It leaves a trailing white space in the input buffer. So, let me run this program and show you the problem is. So if I run this and type in hello space world, I get nothing because I didn't see out anything, right? Okay, let's do that. S1, S2. And when we run it, and we type in hello world, return, we get hello space world. Okay, not quite what we expected here. And if we type in hello return world, if I can type in hello, oh, I don't even get a chance to type world. It just skips the get line. The get line doesn't return anything. So the reason for this is because getline, the way the getline works, is different from double right arrow. So getline 1 reads all leading white space. So that's why we have this extra space right here, is because when we typed in hello space world, the double right arrow read HELLO out of the input buffer, leaving space world in there. And then the getline reads the leading white space and it puts it into the string. So it's outputting S1 space S2. S2 is this space world. Okay, because we're doing a space right here. And then it reads all leading white space, reads one character at a time into S1. S2, I guess, right? We're doing it into S2. Reads character at a time into S2, and then stops when it encounters a new line, and it discards the new line. So these two things act very differently. Double right arrow eats, by eating I mean it reads from the input stream and throws it away. It doesn't do anything with it. It eats white space, eats white space, eats white space. So if you type in, for example, hello world like that, all that leading white space gets discarded. Okay. So it discards all leading white space. It then reads HELLO out of the input stream. So as it's running, it sits here and goes HELLO. Oh, the next character is a space. Stop. And so S1 gets hello stuck into it. So hello goes into S1. Now what's in the input buffer? It starts with a space. So itsy bitsy hello world went up the water spout. Nice, very nice. When the get line runs, it reads the white space, and so white space goes in there. So S2 is going to have white space WORLD. Then when it encounters the new line, it reads it and discards it. So getline discards trailing new lines, and double right arrow discards leading white space. And these things are not symmetrical. They do not play nicely with each other. It is poor design, in my opinion, because they don't work together. I'll show you in a second. So this is going to read in, that's the space character, WORLD. Okay. And so what happens if we have a new line here, though? So if we have a, unerase all this stuff here. Look at that. All right. So if we have a new line here in between hello and world, then what happens is this. CN double right arrow S1 reads HELLO. Oh, there's white space. Stop. Then getline reads until the next new line character, which is there. And it discards it. And it returns empty string. So S2 is empty string. And so a lot of students solve this by just doing a second getline. Right? Because that just, the first one throws the new line away, and then it reads the world and everything's fine. Except if there's a space here, in which case the world is actually right into here, and then you're throwing it away by doing the second one. So that's not actually a good solution to actually do two get lines like that. And also you have to keep track of what was the last thing that happened to me. Was the last thing that happened to me a double right arrow, or was it a get line? And you have to and if you have a big complicated input parsing thing, it gets really annoying. And so it's a lot better to just do all double right arrows or all get lines. So you're encountering the same problem, yeah. And so, like I showed you guys on the last two homework assignments, you can just use getline for everything, especially since the input data for this assignment is all tab delimited, right? So you can just getline, and grab a tab, grab until a tab, grab until a tab, grab until a tab, and then use either stoy. You can use a string to integer, you can convert a string to an integer, or stof, string to float, or you can use string to double to convert the letters that you read in, 3.1415. That goes into a string, and then you convert that string into a number. Or you can use read library, because read library does not have this problem. And a student in the previous class was like, well, I want to learn the standard library because, I'm not going to have your library when I go somewhere else. And that's true. And that's why I kind of keep my library a bit on the down low, but at the same time, showing you how it could work is also it kind of helps you understand why the standard library sucks at it. So the rather than all this stuff, we could do string s1 equals read. Please. Yeah, whatever. Nothing. We didn't have a prompt, did we? And then for this one, I'm going to say string s2 equals readline. And that's it. So if we do this and type in hello world, type in hello world, look, there's no extra space. If we type in hello world, it works. It just works magically. Because the C++ standard library's system of using CN is garbage. I was going to say that. I've used it for, I don't know, 30 years now. And I eventually just got annoyed enough to just make my own version so I don't have to use it anymore. There's also one other way of doing this, which is using get, which we haven't done, GET. Which reads one character at a time, and that would give you an H, an E, an L, an L, an O, a new line. So you can do that. You can also tell double right arrow to not skip white space, and so it won't throw away leading white space and things like that. But yeah, the upshot here is to not mix them, or if you do need to mix them, there is say dot ignore. And it can throw away characters in the input string. And so what you can do is you can do a CN double right arrow and then a CN dot ignore 1, and that'll throw the new line away. So you do a double right arrow, get hello, CN dot ignore 1, boop, throw it away, and that is acceptable as well. So double right arrow, you do an ignore, and then a get line. That's pretty standard, right? So that throws away 256 characters up until the next new line, right? And so this is the sort of standard method for it's a liaison between a double right arrow and a getline. You stick one of those things in there and hope that there's not 256, more than 256 characters until the new line, because it'll break if it is. Okay. You guys understand? CN gives you one letter at a time. And okay. My tendency would be to recommend they just use readline for everything, but I do appreciate that desire to get the standard library down. So yeah, it's probably a good experience for you to suffer. It's the catchphrase of every professor. Why do you make your students suffer? It's good for them. Right, because if there isn't that little bit of pain, it's not learning, right? It's only learning when there's that sense of being punched in the face a bunch of times. It builds character exactly. Okay. So, and bugs, yeah. Yeah, my code. There's one area where it doesn't work the same, which is getline. If you hit return for getline, it enters an empty string. For mine, it's like, no, you wanted a string, you're getting a string. So readlib works a little bit differently. It says, if you're telling me to read until an integer is read, I will sit there and read until an integer is read. You are telling me what you want, and you're going to get it. If you did this with, instead of a string, if you did it with like a int or something, if you it's not a bug exactly, it's just poor design. They don't play it, the library doesn't play nicely with itself, which is hello, my name is 7, goodbye. So that gets thrown away, that gets thrown away, that gets thrown away, that gets thrown away. 7. So you know all those problems of like trying to stick a number, and you're trying to read a number and somebody types in squirrel. Readlib just discards anytime they type in something that doesn't match. Nope. Okay, it's 7. I know what you are. All right. And then so S1 int is now S1, which probably shouldn't be S1. It's not a string anymore. I1. There we go. Try typing in decimals, letters, booleans. Doesn't take it. 42, it does. So it's a different philosophy for doing input. Like the way that readlib works is you're like, give me an int, and it will give you an int. The only time it'll fail to give you an int is if you close the input stream entirely. So if the input stream is closed, like the network disconnects or the file is empty, then it returns 0 or whatever. But yeah, it's learning how to work with the standard library is good. It's good for you. Following the standard library to add your read function. I proposed it. I've proposed it twice, and they said there's just not enough people who use Iostreams these days that they don't. There's no need for a better one. So, regardless of the fact that literally every example, right? Like, give me something. Give me some function on CP2 reference, like some math function or something, or a container or anything. Just type something. Quadratic formula. All right. I don't even know if that's in there. All right, let's look at lerp. Why not? It's not the quadratic. Look, see out. It's right there. Like literally every example ever, on every website for C++ uses Iostreams. Like it's just a pet peeve of mine. It's fine. It's fine. I'm okay. Geometric the point is, no matter which page you look at, they all use Iostreams. And so the notion that they can't have a better one is also belied by the fact they just came out with a better version of cout. So they've replaced cout with something better. So I think they should replace cin with something better also. You know. What do I know? And to be fair, more people would need to use this because there is... I don't know if you'd call it a bug, but it's the kind of thing that you want. Like before you make it as part of a standard, you know, you really want to have 1 million people using it and hammering at it and really being sure that it works right. And yeah, a fair number of people, hundreds of people have used it, but not thousands, not tens of thousands, not millions of people. So it would probably be premature to do it anyway. You'd probably want to put it into like a technical specification or something like that and let people hammer on it for a while. What's a better version of cout? It's called format, FMT. And we have time, we'll get to it today, but we got a lot of things to discuss. So, range-based for loops and vectors. Okay, so do you guys remember how to make a vector of vectors, a 2D vector? By the way, I read the C++ 23 standard is probably going to be finalized in February, and it looks like vectors, not vector vectors, but like a 2D vector. You know, like a matrix, like a 2D array. Looks like it might be in the standard. So I'm gonna, I don't know. And if you were here for the 12 o'clock class, I said something a little different. I said it may be coming, may not be. But in the meantime, I actually checked on it. It looks like it might make it. I don't know. It's on the agenda in February. So can you use readline instead of getline? Yeah, of course. You can use either for this homework assignment. You just have to choose for yourself which version you want to use. They play well with each other. You don't have to use either readline or getline, but if you're going to be using the read library, you should probably just use it because it's just better. Sorry. But yeah, 2D vectors or matrices are coming. So vector of floats, because we're making a type system, right? The type system's a 2D array of floats. And yeah, you can yell at me, it's fine. Constant size t, wow, size underscore t size equals 4. And so we're going to make a 4x4. We're going to make a little type system. I don't feel like typing up an 18x18 or whatever. I'm going to make a 4x4. Okay, like my own little mini Pokemon game. Okay. Vector of floats called float list. You could do it that way, but I like making a 2D vector all at once. I like just declaring it as a 2D array. You could do an empty vector of vectors and then add a row at a time, and then resize each row out to the size. But that's a lot more lines of code. I like doing things on like one line, and I like having my code sort of initialized, like, you know, like kind of properly. So we'll call you mat because it's a matrix, and it's going to be of size 4. So there's going to be 4 rows in it, and each row is going to be a vector of floats, also of size 4. Okay, size. Parentheses were disambiguated. Vector of floats. What did I do wrong here? Vector floats. T. Literally the same code. Const. Wait. It's the previous line, I think. Yeah. Okay. Const size t. Yeah, I was going to make it a constant, and then I thought to myself, wait, no, it's a vector. Sizes of vectors have to be size underscore t, so I just kept typing instead of erasing. Good to know. All right. So we've made a 4x4 matrix, so it holds 16 numbers. And we want to do something like cn into it. And you guys aren't going to be cnning into it. You're going to be reading from a file. But you guys should know by now that reading from the keyboard and reading from a file is like one line of code different, right? You just use an Iostream. Set up Iostream ends parentheses double quote type underscore system dot text. right? You just one extra line of code to open the file, and then rather than cn, you use ends, and you read from that instead of cn. It's identical code. So I'm just going to show you how to read from the keyboard right now. Okay, Q, explain the mat part. The name of the variable is mat. So I know it's a break from tradition. Normally I call them vec because it's a vector, but in this case it's a 2D vector, so I'm calling it mat because it's a matrix. So, call it vec. Yeah, okay. No, we're gonna call it mat. We'll just call it mat, like mat. All right, so now I'm going to show you guys how to read into a 2D matrix, 2D vector, whatever you want to call it, using range-based for loops, which is a little bit different from what we've done before. So you can say for auto reference row. So for every row in the matrix, for every column in the row, cn into the column. So row is of type vector of floats. Row is going to be one row of data. And then for every element in that row of data, it's going to be a float. This is basically a float, right? It'll cn into it. And then if we want to print it out, we can do the same thing, but couting into 5, y5y, p, and cout the value, and have a new line after every row. So for every element in the row, we're going to print out, and we probably need a space after it as well or something. Right? So we'll print out each column on each row with a space in between each one. When we get to the end of the row, we do a new line. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So there you go. So it read in 16 times, and it printed out a 4x4 matrix. So the first 4 numbers I read in was from the top row, right? 1, 2, 3, 4. So 4 elements of the first row. 5, 6, 7, 8. Elements of the second row. 9, 10, 11, 12. Elements of the third row. 13, 14, 15, 16. Elements of the fourth row. Any questions about that? Kind of cool. You could do this with a traditional for loop. For int I equals 0, I is less than, mat.size, I++. You can do it that way if you want to. But I kind of like the look of this. Questions about it? You're confused with how it is initialized. This thing here? Or this? So what this is doing, so vectors have a constructor. If I want to make a vector of ints named vec of size 10, and I want to set every element of the vector to be 420, I do it that way. Okay, so this creates a vector named vec, size 10, every element in the vector is 420. So what this is doing, it's making a vector named mat of size 4, and each element of it is a vector of size 4. So it 4 times makes a row of size 4. My advice is just to sort of memorize this pattern here. I've typed it enough times that I can do it. But you know, in a couple of years, we might actually have the matrix class, which is really nice because, you know, in all these books that I have, you know, Bjarne's Modern C++ and all this stuff, they always like, all right, there's no matrix class, so we're gonna have to make one, and they run you through the exercise of making your own matrix class, and so everybody has their own matrix class, and none of them are interoperable. And it's the kind of thing where, like, if everybody is doing something, like if everybody needs like a POW function, like it should be in the standard. You know what I mean? Like, the whole point of having a standard library is to keep people from wasting their time repeating stuff that's already been done before. And literally everybody, every company I've worked for, every major project I've worked on has implemented some sort of math library of some sort. You know what I mean? Like, it's like a student that was in IS50B, he made math.h, you know, and he made his own matrix class and 3-element vector class and made a plus operator so you can add vectors together, and he made a matrix class that you could multiply matrices together and stuff like that. And like none of that, it was a good exercise for him, but he shouldn't have had to do it. You know, it's when everybody has to do something, and it's kind of tedious and repetitive to do that too, because you have to do plus and minus and multiply and divide. And vector plus vector, and then vector times vector, but there's two different times. There's inner product and there's dot product, and there's also vector times scalar, and scalar times vector. It's just like it just kind of annoys me, you know, that everybody has to do it. So anyhow, this is how you do it right now for another couple of years. So you're making a vector of vectors, and so each element of the vector, all 4 elements, has a vector of size 4 within it. So 1, 2, 3, 4 rows created. Each row is a vector of size 4. And because I didn't specify what value it should be initialized to, it will be initialized to 0. Now for the type system, I might actually want it initialized to 1, right? But it doesn't matter because we're going to be overriding it right here anyway. So let me throw this into a function. 5d5d, paste, void read matrix, taking in an auto reference mat. And then I can just say read matrix mat. And then these 5 lines here, nope, these 6 lines here, I will turn into a function as well called print matrix, taking in an auto reference mat. Okay, so if I have one matrix of like floats, and then I can make another matrix of like strings, vector of strings named mat2 of size. Each row on it is a vector of strings of size. Okay. So this makes a 4x4 matrix of floats. You're going to do something like that for your type system, except it will be bigger. And this makes a 4x4 matrix of strings. Now check this out. That function that I made, those functions that I made, I should say, for read matrix and print matrix, they work with a vector of strings as well. And the reason why it works is because I put auto here. Okay, so auto will work with any type. It deduces the type from the type that is passed in. So if you pass in a vector of floats, then mat is a vector of floats, and each row will be a vector of floats, and each column will be a float. If you pass in mat2, then mat is a vector of strings, row is a vector of strings, call is a string, and auto just deduces the type automatically. It's really nice. It allows you to write Python-esque or JavaScript-esque code where you've got no real type information on it. Now, yeah, this will work, so I can run this and show this to you. Yeah, there's the 10 420s. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then, okay. What happened here? It didn't read the strings. Why didn't you read the strings? You can. Yeah, you can use auto as a parameter type. I don't like writing code like that, though. Oh, guess it's mat, not mat 2. Copy paste error. Classic. Classic. Copy paste error. Every time you copy paste code, you should scan it over so you don't do what I just did there. A, B, C, D, E, F. Hello. Goodbye. Okay. And so there it is. There's the matrix. Okay. So now the trouble with this is that what if we had, like, I don't know, something that's not a matrix? Like this read matrix, it takes anything, right? It takes anything. So I could technically call read matrix on size, right? And guess what? That actually is fine down here. It's fine down there because read matrix takes any parameter type. It's not good. I mean, it is good for being flexible, but when we come up here and we say for every element in size, for every element in an integer, that doesn't make the slightest bit of sense. All right. Range-based for loops work on container types. They work on things like arrays and vectors and unordered maps and things like that. And an integer is not a container, right? But the kicker is that the compile error is up there, not down there. Because we made the mistake down here, you know what I'm saying? Like, that's wrong. Like, you shouldn't be able to call read matrix on something that's not a matrix, right? So, in the previous class, a person suggested, well, could you do this? Could you do this instead? Say a vector of anything. You guys see that? You guys see what the student wanted to do? Or former student wanted to do? That makes sense what they're attempting to accomplish? It doesn't work. But do you guys see what they're trying to, like, kind of get at? Like, I want to only take vector of vectors to this function. Right? But it could be a vector of anything. Right? Because this code here will work with floats, as strings, or bools, or, you know, right? You guys, does this kind of conceptually make sense to you what they're trying to accomplish here? Like, I want to restrict this function because auto, when you do this, like, it'll work with anything, except it doesn't, like we saw with this line of code here, right? So we want to restrict it just to vectors of something. To read every value in, what is it? String, int, float, keys. To read every value in, it'll read in any type, but this doesn't work. What you have to do instead is something that you learn in CSI 41, but it's not that complicated. You just do this. So this is something that's a CSI 41 topic. You don't have to know it, but it's kind of cool. And all of you should take 41, by the way. Like, there's kind of no point taking computer science for one semester and then not finishing it off the second semester. Because it's really 2 semesters to learn how to program, right? And learn C++, learn how to program. After 2 semesters, you're capable of getting a junior developer position. That's when I got my first job as a junior developer after 2 semesters. And if you take 1 semester and quit, you're going to forget everything. And, you know, I mean, I guess some people take 40 only just because they're like a math major, and math majors only have to take 1 semester. And they're like, I'll just keep my head down, get a C. I'll never have to program again. And they get into junior level and senior level math, and they're like, wow, it's all programming. I sure wish I had taken 41. Do you recommend 41 next? Yeah, absolutely. For 100% of people in here. The only people that I would recommend not taking 41 is if you don't know 40, then I would take 40 again. Like, even if you like somehow manage to like get a C in the class by like leaning on your partners a lot, and you know, picking up easy points where you can. If you like if you don't know what a function is, like you're gonna have a bad time in 41. You know what I mean? Like you gotta know what a function is. You gotta know what a for loop is and an if statement. Like you gotta have those basics down. You know, how do I make a basic class? You know, none of the complicated stuff. Just because we go over a lot of stuff for classes and object-oriented programming in 41. Just, you know, like the basic, like a struct, you know, kind of thing. That's a bunch of variables living together. That's all you need for 41. Can you take 40 and 41 at the same time? No. It's like asking, can I take Japanese 1 and Japanese 2 at the same time? No. It doesn't make any sense. Like 41 is literally the second half of 40. You know what I mean? So it continues where 40 left off. And after the end of a combination of 40 and 41, then you know how to program. And you don't really learn how to program after that. Computer science is a 4-year degree, where the first year is spent learning how to program, and then the rest of it is your programming. And you're going to learn more programming techniques and things like that, but that's not really the point. The point of computer science degrees is not to teach you how to program, to teach you how to, like, write code. You have to know it, which is why we teach it, but you know, when you get into discrete math, you're going to be using your coding skills to do things like solve what's the fastest route from San Diego to Portland or something like that, you know. Teach you how to do logic, sure. I know someone who took OChem 1 and 2 at the same time. I wouldn't recommend it. So, yeah, you'd probably have to petition that. Like, maybe if you knew it already, like, they would let you do it, you know. Okay, so if we do this, look. Now the error message has moved down here. You guys see that? So now the error message makes sense. You can't call this because the parameter type doesn't match. This is why we do typing. This is why the type system exists in C++. It's to catch errors early. And a lot of languages like Python and Java have a very weak type system. And they would allow you to just, like Python and Java looks like this. Like you can just make a function and just call it and just hope it works, you know. So you're dead at 40 and 41 at the same time because you had taken them already. Yeah. Like in a situation where you already know the material, like I'm fine, you know. Like it doesn't bother me. Okay, but this is good. This is good. So what this code here is saying is it's saying it's basically saying vector of auto. Like that's basically what it's saying. Like any vector of vectors of any type will work here, except that technically doesn't work in C++. You have to do it this way. So type name T, template type name T means T is some type that's like fill in the blank, right? So it's like writing this. Like there's a giant blank here, and it'll work with any type. You know, it'll work with a vector of floats. It'll work with a vector of strings. That's what the T means. The T just means to be decided, to be determined. T for type. I don't know. Does that make sense to you? So like this code here will work with any vector of vector types. It will work with a vector of vector bools, a vector of vector events, a vector of vector of strings. Does that make sense? It is a 41 topic, but I don't think it's that esoteric. It's just nice to have a function that'll work with any type of vector vectors. You know what I mean? You guys have questions of it? Like there's silence on Discord. So we can do the same thing for print matrix. So template type name T, and so we're just going to constrain this a little bit. Vector of some type. So you could just leave it as auto if you want, but it is nice to have, like, what are you expecting it to be? You know, I'm expecting it to be some sort of vector of vectors. It's kind of a safe placeholder. It's really not too different. It's really not too different from this, right? It's just whereas before it would work on an integer, like you could pass an integer to print matrix, which makes no sense whatsoever. Instead it will work with any vector type, and so it's open-ended. It'll work with a lot of different types, but only types that are 2D arrays, you know, or 2D vectors. Set a foo auto thing, take in So foo auto can take in a vector of vector events. Yeah, it can. Yeah, like that's fine. You can pass a 2D array to that. You can pass in an int. You can pass in a float. You can pass in anything. It's auto. Auto will work with anything. It's unconstrained. But this function really shouldn't be unconstrained because it's saying for every element in the material, for every column, for every row in the matrix, for every column in the row. Like it really is expecting a 2D vector. You know, auto is the wrong thing here because auto says, I work with anything. I work with ints, and I work with floats, and I work with bools, and I work with vectors, and I work with unordered maps. I work with everything. And it doesn't. This code only works with 2D vectors. So the proper way of specifying what the student wanted to specify is this. So it's a vector of anything. Okay. So next up is hashtag define, hashtag ifdef. So we've talked a little bit about the preprocessor before. Do you guys remember what hashtag include does? Because anything that starts with a hashtag, a pound sign, the number key, I've heard it called. Like that's bringing it back old school though. Do you guys remember what hashtag include does? Copies and pastes all the code from that directory. Not from the directory, it's a file. It's a file. So it opens up a file called vector, and it copies and pastes the entire damn thing in. And then it opens up a file called Unordered Map, and it copies and pastes the whole file in. And then it opens up a file called algorithm, and then when they're in angle brackets like that, that means they're installed in the system directory, which is in locate vector include, which is in user include. And so user include is where the system installed header files are, and things like that. Version 9, version 10. And here's the vector class. So the reason why I started talking about the preprocessor thing for the previous class is because I included unordered map, and it actually reduced the number of lines of code, which was surprising. Was not what I was expecting to see. So if you were to compile this code, G++ -E, -E means do the copy pasting of include. Like if we did this, you can see it's copying and pasting those entire files into my file. And at the very bottom here, we've got my little bit of code here. You can pipe it through word count based on line -L. So it's 72,459 lines of code. My little program here is 72,000 lines long. Now, if I were to include unordered map, the line count drops. And I was about to like say, see, this is how big unordered map is. It's that I was like, by including unordered map, the number of lines of code in the project dropped. Which was, yeah, that was my reaction too. Like, huh. So I was like mid-sentence, and I was like, Nani? Yeah. And so then it turned into a discussion of how the preprocessor works. So preprocessors have they work on your program at the textual level. Like your code is just a bunch of text. It's not a program. From the preprocessor's perspective, your code is a Word document. It's a text file. It's Notepad. Okay, so all these things you see with hashtags in them will textually manipulate your program. So you could cut and paste and search and replace inside of your program. And it's kind of cool. It's ugly, and we recommend not doing it as much as possible, but sometimes you can do some pretty cool stuff. So for example, there's this thing called define, and that defines a variable in the preprocessor. So I can define Linux to be true, and then, check this out, if def Linux, if Linux is defined, then I will make this function, we'll just pretend it's like some sort of system call or something, but it's just going to see out. I am calling a Linux system call. Else, see out, I am calling a Windows system call. And of course, allow me to interject, what you call Linux is GNU/Linux, or GNU plus Linux, as I've recently taken to calling it. Now, you might look at this and be like, that's odd. I thought you couldn't have two functions with the same name in the same parameter list. And that's true. You can't. If that would violate the one definition rule. In fact, if I put these two guys next to each other, you'll see that it violates the one definition rule. Redefinition of foo. Can't do it. You cannot have two functions with the same name. But what is going on here is with the preprocessor, it will cut out the block of code as if it's not in your program at all. The C++ compiler will not see one of these two versions of foo. Okay? So it cuts it. And this is really useful because if you want to write a program that runs on Linux or Windows, what you do is anytime there's a difference in the two operating systems, because most of your code is going to be the same, right? Most of your code is going to be the same, but the way that you like read from a mouse or something like that is probably going to be different on the two systems. Or if you want to open a file, it's a different system call for Linux than it is for Windows. Now, we have libraries that do this for us, fopen, Iostream. Iostream works the same on Linux and Windows, but sometimes there are platform-specific differences on how you draw graphics to the screen, read from the keyboard, that kind of stuff. And so what you can do, whenever there's a cross-platform incompatibility, you can do something like this. And then since Linux is defined, that variable Linux is defined in the preprocessor, when the preprocessor gets to here, it says, yes, Linux is defined, and it puts this line of code in. Okay. And then else, nope, not you, and that gets cut out. So if we come down here into, let's see, it's called foo, I guess. Anyone want to take a bet? Anyone want to take a bet on what this is going to print to the screen? I'm calling foo. Here's foo. There's two versions of foo. Anyone want to take a bet on whether it's going to print out option A or option B? Portnoff is putting down a bet on A. Does anyone want to take B? You guys are risking all of the points in this class you have to date, so. In the previous class I said that. And one of the students picked B and got it wrong, but he got the second one, double or nothing, so it all worked out. So yeah, it's gonna be A. So if we compile this and run it, prints out I'm a GNU Linux system call. Okay, so what is it going to print now? A or B? I bet all of your points on B. Yeah, I said bet, I didn't say what the bet was for. And so students were like, it's this. We can all miss, this is double or nothing. Double or nothing. If you get it wrong, you get a 0 in the class. If you get it right, you get double the points. No, I'm kidding. We'll take that bet. No, it would be irresponsible and stuff. I would never do that to my students. I would never make students sword fight me in order to win extra credit. I used to have students during midterms, back when we had midterms. They could come up once during the midterm and play me at a game of Tekken. If they beat me, they got a letter grade on it. Fortunately, nobody ever beat me, so it worked out pretty well. It was fun. It was fun for me because it's very boring to grade or to sit there during a midterm or a final. You're just like, don't cheat. Everyone's saying B. Wrong. It's A. All of you now have a 0 in the class. Alright, so why? Because it's not saying if Linux, it's saying if Linux is defined. If this variable has been defined anywhere, then it's set. So this means if it's defined. It's not if. If it's if Linux, then it would be, yeah, we're on Windows, right? But it's if it's defined. And Linux has been defined. It's been set. Now, let me show you. I'll give you a chance to redeem your grades, because all of you got that wrong. Let me show you something cool. So you can actually define things on the command line parameter here. So what do you think it's going to print out, A or B? -D defines something for the preprocessor, and you actually can compile your code differently. And this is very common, right? Because like you'll have the same source code, and you just have to either pass in -D Linux or -D Windows or whatever, and then it'll compile the code either a Linux version or a Windows version without you having to modify your code or comment things in or comment things out and stuff like that. What do you think, A or B? Double or nothing. You need to recover your points. All bets are in. Yes, it is A. Okay. So Linux is defined. All right. So do you guys see how that's useful, though? And another very common thing to do is do something like this. If def debug, no, actually like this, void, yes, I know, void debug print, okay, you guys see what this is going to do? So it's very common for me to tell you to see out all the things, right? But at the same time, it's kind of annoying to like, all right, I've seen out all the things, now I need to turn them off. And then you have to like go through your code and like find all the cout statements that shouldn't be in there and take those out and leave the cout statements that should be in there in. And there's a better way. And the better way is to do this. And this is actually used at a lot of companies. The companies I've worked at too used this. It's built in kind of by default in Visual Studio. When you compile code in Visual Studio, you compile it either in debug mode or release mode by default. That's kind of how it's set up in the system. And so what you can do is something like this, like dprint main is starting. You know, let's say your code's crashing or something, right? And then, you know, about to read the second matrix. You know what I'm saying? Like, you can like put these debug prints in, and if you compile the code without defining debug, it doesn't print. But if you compile your code with -d debug on, that defines debug for the preprocessor, and all the cout statements appear in there. Kind of cool, huh? About to read the second matrix. And so you just very, very quickly enable or disable, and all of them, you know, turn on, all of them turn off, and yeah. Sometimes you want more fine-grained control, and I've had projects where like I'll have like -d debug main, you know, or whatever, like, and it'll turn it on just for one file or something. But yeah, it is super useful. It is super useful, and you can just selectively enable and disable code, and it's nice. It's really nice. And that's you can pass that to the compiler. So the compiler, you know, in your make file. So you can type like make debug, and if you type make debug, it turns on debugging for everything. And if you do make release, then it turns off debugging for everything. There's all sorts of ways we do that, but super useful. Yeah, the preprocessor is really useful. It looks kind of gnarly because it's not C. It's not C++. It's its own like program. Like the preprocessor runs before the C++ processor runs. It's its own deal. It's its own gig. Like it doesn't know anything about C++. It will just simply do a textual substitution. So if we hashtag define Linux to be true, then everywhere down below the word Linux appears, it gets substituted with the word true, basically. So I could, for example, cout Linux. I'll turn on bool alpha. And so hashtag include is like Control-C, Control-V, copy, paste. Define is like search and replace. So every time down below, anywhere in the code down below, you see the word Linux, the word true will appear there instead. And I could define it instead to be, I don't know, 42. And it's 42 now. So it's literally like search and replace. Control F, search and replace. End if ends it. So whenever you have an if statement, the hashtag if, it has to have a matching end if with it. And there's else, and there's also elif. There's also elif apple. Okay. So if Linux is defined, it prints out I'm calling it GNU/Linux system call. If Apple's defined, it says I'm calling it overpriced system call. If neither of those are defined, then it says I'm calling a Windows system call. And that's pretty normal. Like if you then where's it? Yeah. So look, this is cimage, which you use for your image processing assignment. So if not defined cimage version, define cimage version to be 3.0. It does all these includes. If not defined, what OS I'm on. If defined, Unix or underscore Unix or underscore Unix underscore then it defines the OS to be 1. So this thing is defined to be 1 if it is on some sort of Unix-like system. If we are on Win32 or underscore Win32 or underscore Win32 underscore or Win64, then we're on Windows. Otherwise, we're on 0, which is an unknown operating system. So it understands Unix-like, it understands Windows-like, and then it just gives up at that point and sets OS to be 0. And then if it's set to anything other than 0, 1, or 2, then it hashtag error will throw a compiler error. It'll just be like, nope, not allowed. So you can see these preprocessor stuff are used everywhere. Disable warnings. If not define this, define this. If the OS version is Windows and MSC version is defined, then it does these things. Otherwise, it does these things. And so very common stuff. Like in professional code, preprocessors are used a lot, and it's a bit unfortunate that you have to, because it's kind of ugly. But that's that's how professional code is. So there's a lot of, look at the standard library, it's a lot of preprocessor stuff. So yeah, end if just has to end the whole block of if statements and things like that. So one last thing I'm going to show you is I'm going to make a little map for like at some point you're going to need some sort of function to convert from a string like dragon type into like what row it's on, like 13 or something like that. And so I recommend just doing a function of some sort. So like size key string to row or something like that. I don't know. Not string size key. If you guys have any other questions about preprocessor, there's a lot to it, but it's all pretty straightforward, I think. Just copy and paste, search and replace, cut out code, paste code. Okay. So you can do things like this. You can say if s double equals normal, return 0. Like you can just write this. You're gonna have to have some sort of function to do this, right? Fighting, and it's kind of annoying because there's a lot of types, and I'm going to show you the way that I'd prefer to do it, and that's using a map. And so if we create a unordered map as a global, unordered map between strings and size t's, named umap. So this will be the map. I don't really want it to be a global though. Globals are in general a bad idea, and if you can make them not globals, it's better. And so what I'm going to do is I'm going to actually make it a global that is only accessible within this function. So static, the static keyword says it's a global. It's initialized at runtime when the program runs. It gets initialized. This thing does not go away when you hit the close bracket. It does not follow the rules for a regular variable. It is a global. It's just always, it always exists. It's the alpha and the omega, right? So even though this is within the scope here, it does not get created here. It does not go away there. It is permanent. Any changes you make to this thing are permanent. That's what the static means. It's not a regular variable. It's a static variable. Okay? It doesn't go away. It doesn't get created. It doesn't get destroyed. It's static. So we can then do things like this. Umap normal is 0, and umap fighting type is 1, and umap book type is 2, and umap Neko-chan 3, something like that. Okay, do a little 4x4 thing. So we're reading our type system down here, right? The whole point of what we did down here was that we're reading in a 4x4 type system, and then we're going to have the user input like enter a type normal for the attacker, enter a type for the defender, fighting. Okay, and then you're going to look up in the type system normal fighting half damage. Okay. And so you're going to do this for your assignment. It's just going to be bigger. Okay, so at some point though, you need to have that mapping from like fire, the words fire, double quotes, to whatever row or column fire is. Okay, and so return umap s. Okay, and to do bounds check with contains or okay, so basically if they pass in fighting, this function will return 1. If they pass in book, it will return 2. If they pass in Neko, it returns 3. If they pass in normal, it returns 0. If they pass anything else, it returns 0. And it's our bad because we're not bounds checking it. Now, let me show you a better way of doing this. So these 4 lines of code would run every time the function runs. It would keep constantly resetting the type system, which is a waste of time and energy. So what we want is for it to be initialized once and to never change again. So we want it actually to be const, and we want to initialize it with all 4 values. Check this out. 1, 2, 3, 4, 4 values. First is normal, value of 0. Second is fighting, value of 1. Third is book type Pokemon with a value of 2. And third is cat type Pokemon with a value of 3. There. This does in one line what, oh, we can't make it const, right? Because of that thing. Right. So yeah, so that one line there did what all of those 4 lines down below did, inserting into it over and over again. So what's nice is that this will be initialized once and then it will never be touched again. Okay, it'll just be read from. So that's that. What is that, Cameron? Okay, so let's do this. So we're gonna read in the type system, and then we're gonna just be like, all right, what's the attacking type, the attacking move type, dragon? What's the defending move type? Normal. Okay, it does 1 times damage. That's kind of our ultimate purpose for today. So do the type system in Pokemon, but smaller, so I don't want to type in all those numbers. Okay, so string attacker type. For the read, please enter the type for the attacker. Do the same for the defender type. And then we will see out the type modifier, type damage. The damage modifier is let's break it down a little bit. Float. So the attacker is the row. So the row in the matrix is going to be string to row attacker type. So if they pass in fighting, if they type fighting in, fighting gets passed to this function here. String to row returns back. It's on row 1. So this is going to be row 1 if they type in fighting. And if they type in Neko as the defending type, then string to row will return 3. And then we're going to look up in this 2D matrix here, row 1, column 3, and that's going to have our multiplier. Mat dot at row dot at column. And there we go. So that is, you have to bounds check, you have to do a lot of other stuff. That's the basic idea. So normal type versus normal type, 1 times multiplier, normal type versus fighting type, half damage, normal type versus book type, normies don't like books, double damage, normal type versus cat type, I don't like cats, okay. So fighting type versus normal type, double damage, fighting type versus fighting type, single times damage, fighting type versus book, fighting types don't like books either, fighting type versus cats, normal damage, book type versus normies, double damage against fighting type, regular damage against other books, half damage against cats, cats do double damage against normies, single damage against fighting type, half damage against books, and regular damage against the cat. So there's our type system that I just typed in. So you can see, like, if I type in normal and fighting, normal for the attacker and fighting for the defender. Alright, that didn't work. Damage multiplier is 1. That's not right. Alright, let's debug this. Yeah, copy paste. Look at that. Look at that right there. That copy paste there, right there. Defender type. There we go. Every time you copy and paste. Every time you copy and paste, always scan so you don't make that mistake. Now I got to enter these numbers again. No, I don't. I'll just copy and paste them. All right. Yep. There we go. Okay. So if we have normal type versus fighting type, it's 0.5. Okay. Normal type versus fighting type, 0.5. You guys understand? So what we did today was we loaded in a 4x4 matrix using a range-based for loop instead of a regular for loop, just because it amuses me. I don't know. I kind of like the look of this. For every row, for every column in that row, yeah, I like it. So we write in the type system. We then read in the attacking moves type, not the attacking Pokemon's type, the attacking moves type. So if you do Fire Spin as a normal type Pokemon, it's a fire type move. It's not a normal type move. It's a fire type move because it's Fire Spin. So if we typed in fire, then it converts from the string fire to whichever row or column fire is, 5 or whatever it is. I don't know off the top of my head. and then you type in the defender's type. You're going to have to do the defender's type twice because they can have two types and they multiply together. So if you type in like water, then it would return whatever row or column water is. And then you look up on the type matrix the row for fire, the column for water, you get 0.5, call it a day. So that's basically this is what you have to do for Pokemon Part 2 in a nutshell. Obviously more, but that's kind of the essence of it. You've also learned about preprocessor stuff today, which you don't need for the Pokemon assignment, but at the same time, it's the kind of thing that at some point you kind of want to learn. Like, you kind of, this is all like actually really common and very useful stuff. And you know, today turned out to be, I guess, the day for it because I was trying to show how many lines of code Unordered Map had, and it went down. And the reason why it went down is probably it defined something that turned off another block of code or something. I don't know what. I'd have to look at it really carefully to figure out why the line count went down. But yeah, probably. And if you move these includes around, you'll actually see the number of lines of code in your project change. It's like if you change the order that they're included, it changes actually how many lines of code you have in your project, because they're going to be defining things at different times, saying if this is not defined, then define it, and so it's kind of an interesting discovery, and so it led into a discussion of all this bright red stuff here that we see. So yeah, super useful stuff. Not for Pokemon, just in general though. This deprint thing, like that's a lifesaver. One thing I'd probably change that to is C error. And in reality, in major programs, you're not going to be C-outing things. You're usually going to be writing to a file. So usually your deprint function, or whatever you want to call it, is going to be writing to a file, error.log or something like that. So that when the code crashes, then you look at the error.log file and you see, oh, I see, I was in this function here and doing this. And C-error is like C-out, except it's not C-out. There's a minor technical difference between C-out and C-error. They both appear on the screen. They don't go to a file or anything like that. But C-error is different from C-out, and so it does not get counted by the autograder. So anything you deprint, if you use this version of deprint, nothing you deprint will get counted for the autograder. So pro tip right there, because a lot of you get worried that like I don't want to C-out things, because if I C-out things, I'll fail the test cases, right? So just instead of using C-out to debug your stuff, use C-error instead, and the autograder will ignore it. It's a good pro tip right there. Like seriously, it's actually pretty good. All right, that's it for today. Get cracking on your Pokemon assignments. I think one person said they wanted a new partner, so I will re-partner people. You like Sierra? Yeah, it's nice. I would just always use it for your debugging stuff, just so it never gets picked up by the autograder. It's a good habit to have anyway. All right, peace out, you guys. See ya.